All right, good morning, everyone. Welcome to the Subspace Developer Front-End App Sync. Today, we're not going to talk too much about front-end apps, but we are going to talk about the JavaScript side of what we've been doing in Subspace.js and the relayer more. Let's see, Leo, if you'd like to start off with your updates, please.
I have mainly more than Subspace JS task. I have no updates on that actually. I do have some ideas about how to make a project structure around it. And I basically was testing my previous TypeScript interfaces generating script, and it's actually working with the last Polkadot API version, because now they have like inserted everything in terms of types, not only the types, but the names and everything. And with some tweaks, I was able to generate a lot of interfaces with a couple of errors, like for future uses, basically. And after that, I have been working in this Terraform repository, where I am basically, I take the freedom actually to define all the infrastructure for the testnet and for the relayer and a couple of several others topics. For example, the other day, Serge asked me for the relayer logs, and I wasn't able to extract them from the virtual machine, and I just run an SCP command to copy the logs and share it from my local machine to Google Drive. And I started to investigate how we can manage this monitoring. How to add to our infrastructure actually a monitoring tool for all the applications. And as we use Docker, we can maybe use. I was having this idea of creating a dedicated or centralized machine to get all the logs and expose them in a web tool for monitoring all the logs in a remote way. So I was defining the ELK stack, Elasticsearch with FluentD and Kibana to expose all the all apps logs in a Kibana dashboard, actually. So I have been working in that, and I think that today actually Serge asked me to launch a boot node and a testnet to start testing the relayer from the archive. So I think that after this call, I will be testing these deployments regarding the creation of a new environment with the relayer and everything. So I've been basically working in that, and I think that today I can finish this and share it with you guys. It's a lot of documentation actually, because I tried, like I said yesterday, I tried to compile everything that we have doing until now, from a simple droplet launch and configuration up to the relayer app running. This actually include everything from the public domains configuration and definitions up to linking everything. Just trying to share with you what we have now, what's the current state of our developments and of our infrastructure.
Okay. Sounds good. That's not really my area of expertise, so I can't really comment on that, but it sounds like it's something we need. Does anybody else have any feedback on that? Nazar? Are you there, Nazar?
Yes, I am.
Okay, so you don't have any feedback? Okay.
No.
Okay.
I was with this feeling that we were like kicking a lot of tiny things, really tiny things. Like, for example, using DigitalOcean, just creating in this, having this Terraform way to do things, and a lot of other things that when I summarize everything, it was a lot of pending tasks that we were like kicking up, and it was I think it was going to be dangerous after launching the testnet without having all this defined.
Okay.
For example, something so tiny
Can you,
like sharing the
yeah,
logs
sorry to
from.
interrupt. Could you show us how where all this is defined, or it's
Yeah,
okay? Yeah, that would be helpful. Like if you could walk us through whatever you've got committed or
yeah.
how you're doing this.
I started with this, just trying to, like I said, create an overview of everything that I consider that we have to solve for our infrastructure. Starting for these Cloudflare definitions, what are the DNS and the uses that we are giving to those records, DNS records. The same with the CDN projects that we are using, but it's just one for now. After that, super general considerations like these ones in terms of how we define the access to the droplets. Do not use the root user, create a user and allow only SSH authentication with keys and not password, disable password, and a lot of security basic things in terms of virtual machines. After that, how we use in the current state of DigitalOcean, like the machines that we have today, the storage we have today, and again, how to access and authenticate to these resources, and a simple introduction, and we use Terraform and why we use Terraform and how is the Terraform project structure. Another documentation is about we use Docker for everything, trying to have all these standardized in Docker images in our Docker Hub, and how to generate and publish these images, and what are the current public images available. And like I said before, I made an introduction or an idea on how to have this dedicated log management environment to share all the logs of our infrastructure. This is covered only in terms of applications, not system, because the system monitoring can be done for now just through DigitalOcean dashboard. And finally, the requested task that in my mind, I have considered that I have to have like all this clear to get to this point about launching a Subspace network environment in terms of internal workflow, uh, downloading all the blocks and say all this to a local storage, an extra storage to DigitalOcean, how to configure that and everything. And when we are ready to import, right, and then how to launch this ARIES testnet, the boot node, the public RPC, the farmer, and after that, the relayer testnet in both modes, in live mode and archival mode. The live mode is like ready, and the archival mode is I am still defining it. Fine. I got the idea, but I have to write it and implement this. And finally, some consideration about how to deploy the relayer front end and the relayer backend, right? And another consideration on if you are launching this new network, you also have to make this pull request to add this new chain to Polkadot apps. And I basically have an index defining each one of these overview items that I commented right now. And like I said, I will be sharing this, and there are some to-dos that you hopefully you could check, guys, and maybe make some comments if I am missing something or I am getting something wrong. Well, this is the general definitions, and after that we have this DigitalOcean infrastructure guide, how we define the naming of all the resources, a couple of examples on how to define these resources, basically to have a structure regarding like DigitalOcean projects, right? And one project, it could be one testnet or one network, and inside all the droplets we use for this environment. The same with volumes, how we name the volumes to have to just get in the volume section in DigitalOcean and be able to, oh, I am using this volume for this machine regarding this use, right? And this is the size. So the same, some consideration about how to access these droplet resources, like I
Hey,
said.
Leo, sorry
Yeah.
to interrupt. So you're basically building documentation, or are you automating this?
Yeah, I have this in Terraform actually.
Okay, and
For the
this
service
is
testnet.
is this committed to Git?
No, I still not committed this because it's
Okay,
not working. Actually, it's really broken. But I think that for today, I can have something basic working in GitHub.
okay. So is any of this tracked on the board right now?
Other what?
On the board, like on the Jira board, or the on the project board?
In Notion?
Yes.
Yeah, I created a task about this,
Okay.
and I had a link to a gist with all this documentation, the first version of everything in one document.
Okay.
Yeah, and the next step, like I said, I was like putting in order this to be able to share it, because in one file it was impossible to understand in a right way.
So I'm just trying to understand the scope of what we're doing here and what the end state is. So you're basically documenting everything on the deployment side, trying to automate it, and then you're going to commit that to Git, and then I should just be able to run like a command and like,
Yeah, that's the idea.
and then just spin up like a cluster of some, test net or something like that.
Right.
Okay. Okay. Any feedback from the group here? I am not a DevOps guy, so I can't really comment on any of this.
My first comment would be, can we discuss these things before doing them?
Yeah,
For instance, something like log system, it's like a pretty major decision whether we run our own managed system and what that system is, or can we just go with something that is provided as SaaS solution, and that will not be expensive at our point and will be easier to use. So those kinds of things are pretty fundamental and important. And I think it would be nice to have like a showcase of what are the options and what are the trade-offs, and we can like have a collective decision instead of just going full on, building something that like others are not even aware of.
yeah, sure. I actually, just let me share this, because there are several comments in there that said like to discuss with the team if this is the best
Let's
way.
do it right now. That's what we're here for. So what are the questions? What are the to-dos?
Basically, my main question are, because in terms of like droplets and everything is like really easy, but my main issue is for example, how we can handle the login infrastructure, how we can check the logs in a real-time way for all our developments. And I was thinking in using a really tested stack, call it the ELK stack, the Elasticsearch and Kibana, and yeah, Elasticsearch and Kibana. Kibana is the monitoring tool for create a web dashboard for the logs, and Elasticsearch is used for storing and searching in the logs. And log stash is the tool to communicate and send all the logs to this centralized server.
So do we need, I guess my first question would be, like, I've used Elk before, it's a lot. Do we really need something that heavy, or can we use like a more simple logging tool?
Yeah,
don't
from
know.
my experience, ELK is quite heavy, primarily, I think, because of Elasticsearch. It's server in Java. It's like very, very big thing, requires lots of resources. I had pretty good experience with Loki. It's tool from folks that develop Grafana. So they like have Prometheus and dashboard Grafana, and Grafana dashboard can also be used to watch in logs. But again, that's like on our own infrastructure, and it's not something that you can deploy once and just forget about it. It needs to be maintained. So the other option is to use something like Datadog, which is just a solution we can just run their container, specify credentials, and they will take care of the rest. They will watch for different containers, they will collect logs from them, they will collect some metrics, they will provide dashboards, and we can just give the whole team access to the like corporate account, so to speak. And basically everyone will be able to see and filter and search and everything. So that might be okay. So in Docker there is actually like different drivers for writing logs. The default one is to write to JSON files, and basically you run a container from something like Datadog, and it monitors those JSON files and reads logs from them and then sends them over somewhere. And you can provide filters like what needs to be sent, and you can also provide filters on import what needs to be discarded. And you can like transform logs, so you can like normalize timestamps, or you can like process structured logs in some way. And then you can build different dashboards, how you can like go through them. So you can like search by application, or you can search across all application within the time frame, or you can search for like specific words. You can index logs. So they're like standard stuff, basically, what you want to do.
I guess even before that, like, why can't we just SSH and pull logs like as needed? Why do we need like a full monitoring service right now?
We can. It's just it gets a little bit complicated over time. And also, if you restart the container, logs are gone. So
we're trying to get the logs out of the container somewhere else.
Yeah, it happened to me actually, that I resetted the networks and I lost the logs when the network crashed, and I wasn't able to have a history of what really happened. And the same for the relayer. It was so big, 200 megabyte log, and finding the error, it was really, yeah, it takes some time, and it's, in the future will be a pain actually, I think.
Okay. Do you guys, Serge or Liu-Cheng, do you guys have any feedback on logs or a simple logging solution?
No, I'm not expert on those.
So you have mentioned the 2 megabytes log files. Basically, Substrate was intended to. I'm not saying. I'm just saying about the logging system. Like if we don't use a formal or professional monitoring tools, monitoring system, like we at least we can use some log rotation. Like we don't want like 2 megabytes or even 1 gigabyte log file, one single log file. So at least we can do something log rotation before we have a professional monitoring system.
Right, but in order to have log rotation, you need to write logs to files. And modern applications don't write log to files. They write it to standard output or standard error. So some tool needs to go and read those logs and write them somewhere in some shape or form.
Yeah.
And at that point, it might be easier to just run a container from some service, and they will just take care of it.
That's also a solution. I just see if we like don't use a professional, like we don't redirect the log to like a container or something.
Yeah, and we also were talking about having a monitoring, not like logs, but monitoring at some point. So to see how many connections we have, what are the usage resources for different applications, and some like custom metrics, for instance, how many blocks are processed by relayer per, I don't know, second, day, whatever. Those kinds of things are usually go hand in hand on many services that provide these kinds of solutions. So you can have logs and metrics, and you can even like correlate them together. It's really quite easy to set up. It's just more expensive than running our own infrastructure, but on our scale, on how many containers we have, I think it's a pretty good option to start. We can like set up it once. We don't need to worry about scaling or anything. Really, just works.
This is just for logging, or this is for our entire infrastructure?
It depends on the provider. I know for sure that Datadog supports both logging and monitoring. And you can monitor servers, I believe. You can monitor applications, just like all in one. Just depends how deep your pocket is, basically.
Okay. Okay. So what do you guys recommend? Let's try to make a decision right now.
I was checking Datadog. It's like the same that this other stack, but you don't have to take care about anything.
It's actually
So
quite
they
a
have a
bit
free tier.
more advanced under the covers. I'm not sure we need any of that, but like it's just there.
Yeah.
So
I mean,
the difference between Datadog and Elk, is it like Datadog, we pay more, it's all just hidden, abstracted away behind the scenes. Elk, it's free, but we run it all ourselves and it's more setup?
Actually, ELK stack, I believe you can order it from some providers, but Datadog is like proprietary solution that they sell as a service. So depending on how many logs you write or how many queries you do or how long the retention time is, that impacts how much you pay, basically. So if you have something really small, you basically don't worry about it. You pay like $2 per month and it just works.
And does it make a difference with Prometheus, with the substrate nodes? Is one Elk or Datadog better, or does it make a difference with either of those?
You would use either Prometheus or Victoria Metrics server and Grafana for visualization, but again, you need to have some Prometheus database to store it. And that again goes into the management side of things. So you need to like maintain all of those servers, configure different policies. If you use something like Datadog, you just provide an endpoint to it and it will read it. So again,
even for Prometheus data?
Yeah, I believe so.
Okay.
So this is like much easier in terms of spending time of our team to get some results. And we can always change it later if you need.
Yeah, and Leo, like Nazar and I mean, for everybody, we're interviewing like lots of people, and some of them might even be like a DevOps person. Like we've identified that we might need like a full-time DevOps person on the team. So while I have no doubt that you could set all this up, Leo, it's probably, we'd much rather just pay for it and have something working and have you work on like Subspace JS, you know, than like spending like a week doing like all this, you know, all this like logging infrastructure. So I think it would be better if it's easier to set up and we just have to pay a little bit more for it, then I would much rather go like with something like Datadog.
Yeah, I agree. I totally agree. I haven't actually launched the ELK stack for the same reason, because I realized it's a heavy task and I wanted to discuss it first.
Yeah, just look at Datadog, maybe look at some of the alternatives. If you find something that you like more, we can look at that. And I think it will be even like cheaper for us, both in terms of how many different droplets we need to run to get it working and visualized, and in terms of just time spent.
Yeah.
achieving the goal.
Agree. I'm going to make a look around this. Yeah.
Okay, so we have a logging question. I think we got that resolved. What are the other open questions in the architecture for this backend? I guess one that comes to mind for me is like Terraform versus Kubernetes versus
It's not
Monk.
versus, it's everything together.
Well, okay. Terraform, Kubernetes, Monk. Are we using all three? 2 out of the 3? Do we?
If we are going to have a dedicated DevOps person, I think that we should just define everything in Terraform. And when this person comes to and enter to the team, he can take everything from this Terraform project and do what he consider best to do. So my idea for now is having all this compiled, so anyone can take this and continue this work. Have some order, something like that. So I am just using Terraform right now, just that.
Okay. Any thoughts on that?
I think whatever works.
Okay. Okay. So Terraform. What about Monk? Is that more work here, or is that helpful?
I am actually really used to work with Terraform, and I know the language and the scripting. Yeah, I have some experience with it before. So for me right now, it's faster to just work with Terraform. Yeah.
Okay. Okay. What are the other open questions, Leo?
Yeah, I have another question that are more, maybe more complex in terms of how we are going to define the resource naming and all that kind of things. Like I want to create a droplet. How can I tag in the name? This droplet is for this testnet and is related to this storage and everything. So I have created a template that actually put the name of the droplet like automatically. Let me. Oh, where is this? Where is this? Oh, I stopped sharing. Sorry. This maybe take some time to discuss actually, because the resource naming for me it's important, because when you get to DigitalOcean, you at least have this project a way to separate things, this project structure, and inside the project you can put x amount of droplets in there, right? So for now, we are working with no projects structure, and we just have one node that contains everything. Yeah, and I was thinking in having a really simple naming project regarding the environment and the project name. And for all use cases, the project name should always be like the area testnet in this case, and the development environment. I was about to create this actually for a really fast example should be right now. Serge need a development environment to test the relayer, and we also have this testnet running, right? And will be nice to have these separated environments where you have the projects like in a structure like separated, right? That just that, and maybe have a third environment for the production after the launch. right? And we this way we could be able to do these blue-green changes, this blue-green deployment. So if this works actually, and the relayer from the relayer archiving process is completed, we can just basically move it to test and then to the production network. And so that's the naming.
Okay, let's talk about that before we move on to the next thing. That makes sense. The way that I would see it is there should be eventually 4 main environments. There should be a dev environment, a staging environment, a test environment, and a mainnet environment. Sorry.
Sorry, you said 4?
Yeah. Sorry, just a second.
Yeah, just add staging to the 3 you have already.
So we don't want to use the word prod because that's really our mainnet, and we don't have a mainnet yet. That's eventually. We have a test net, but we're going to have a staging environment which is in between dev and test, which is like we're backing up the archiver or the relayer from archiving, or spinning up a new test net, and we're waiting for it to get fully seeded, and then we would do a blue-green between staging and test. Does that make sense?
Yeah, I'm writing in my book. Don't worry.
Yeah, and then we should probably have like test or dev, whatever, dash, and then like Aries or Gemini or something like that, like as we move between the different like releases of the test net, because we might have like, you know, staging Aries and then test Aries, and then we might start working on Gemini, so we might have like staging Gemini working in the background, like while we still have like an Aries staging working, like if we have to reboot Aries, for example. So I think it should be like the environment and then the release, like Gemini, Aries, Spartan, whatever, and then probably like some version of that, which we should have like some semantic versioning scheme. I guess we're kind of using that right now. But some way to differentiate between different versions of like Aries. I mean, that's the way that makes sense to me. What do you guys think?
Oh, that's what I wanted to define. So I agree. That's useful information for me.
Anybody else have any thoughts? No, sounds good.
I have a minor comment. Maybe we should put project name first and then like test and staging or whatever.
Okay, so like Aries
Yeah.
test
Yeah,
version.
because there might be sorted at some point alphabetically on some UI, right? And it will be
Makes
cleaner
sense.
to just.
Yeah, that's a good comment, Serge.
Yeah,
Okay.
I'll change that.
And then I guess we also have, so for like relayer, it would be like Aries test. Yeah, then there should be another field which should be like the actual like software that's running. So it should be like Aries test, like boot node, Aries test version boot node, something like that, or Aries test boot node version, and then like Aries test relayer front end version, Aries test relayer backend version.
I mean, for the backend, so for the droplets naming, I think that it's just enough with the boot node itself, public RPC itself, because they are already in the project. So there is no way to be able to see them if it's not from the project. So you already know that you are in this station, in this testnet, and this is the droplet for this environment.
Okay.
Oh, I don't know why My share screen.
Yeah, your video went away too for me. I think maybe it's your internet, Leo.
Sorry. And another general consideration that I want to confirm you is we are going to work with this in terms of droplet access, droplet security. These are really the basic things that I have learned among the years. Like we don't have to use the root user for virtual machines access or installation, configuration, everything. There should be a sudo user for administrator, part of the root user. Maybe the account that the administrator will use, like this DevOps guy.
Yeah, I think this is all pretty reasonable standard stuff. Does anybody? This makes sense to me. Does anybody have any issues with this? Are we good with what Leo's written down here?
It's good, but on the send email part, ideally we would have some kind of provisioning system that would allow us to define like this service should have these users added declaratively, and you just apply like Terraform apply and it will provision everything. But that's further down the road, I think.
Yeah, I think that's we're not at that stage right now.
Yeah.
The other thing is we can use Bitwarden. Like if there's any passwords here or whatever, we should probably just use Bitwarden to manage access to those within the dev team.
Can you repeat the last part? Sorry, I didn't hear you.
We should use Bitwarden to manage passwords for these instances, or any kind of keys that we have for these instances amongst the team.
Yeah.
Who has access to Bitwarden? Serge and Liu, you do not? Okay.
I'm not sure.
Okay, can both of you check with Justin, like task for both you guys, message Justin on Discord, ask him to set up a Bitwarden account for you. And I'll make sure that Justin sets up a dev account if we don't, I don't think we have like a dev folder. No, we do actually for a couple things. So Leo, let's put all this stuff in Bitwarden so everybody has access to it.
Yeah, perfect. Well, these are other obviously things that we use Ubuntu for everything. I think that obviously the latest stable version, and yeah, I think that for now that's are the main things that I have been considering actually. And that's the current way of getting the logs. And yeah, this was already discussed just now. No,
Okay.
this is the workflow. Yeah, I think that's all. Yeah, there are maybe a couple of hidden things in here, but should be minimal.
Okay. Leo, do you think you can get this put into GitHub today and get a PR so that everybody can get a chance to review this and give feedback outside of the meeting as well?
Yeah, sure. It's the next.
It's a draft. It's a draft PR, so it doesn't have to be finished. It's okay. We just it's better to get feedback from everybody before we commit to a specific direction. I think we've got some better definition, but there's probably some more minor details that we're missing here.
Yeah, there are a couple actually. Okay.
And I'd like what I'd like you to do, Leo, is try to wrap this up like in the next day or two, so that we can start working on the front end apps, Subspace.js. That's really the priority here.
Yeah. Like I said, I think that at least in terms of documentation and workflow and the basic scripts, I can finish this. I was hoping to finish this today. So I already have like 3 days working with this. It's enough.
Okay. Are there any other feedback or comments on the on our infrastructure? Any questions? We're good? Okay. Leo, I know you said you haven't done any work on the front-end apps. Is there any feedback or comments on the front-end apps from the group, like anything with the Relayer or Polkadot.js, any issues that we're seeing that we need to discuss right now?
Oh yeah, I just have one feedback, so one task with advances. Yeah, I discovered a way a workaround to fix the block time in Polkadot apps without needing to add a line with our Subspace module. So I will be closing that, I hope tomorrow, yeah, and sending that peer.
Okay. What was the way?
Sorry?
What was the way to fix it?
Okay. Yeah, extending a part of the library in terms of const and made a lookup in the RPC const and extract the expected block time no matter where is stored. So if it doesn't matter if a const of Babe or Subspace or Aura, this hook is able to extract it in the correct way.
Okay. Okay. I guess we can move on now. If there's anything else you wanted to cover, Leo? Are we good? Okay. Let's talk about the relayer. Serge, if you want to give us an update on what's changed there.
Okay, yeah, so I've been working on processing para blocks from archive, and that was actually implemented and it's currently in review. And yeah, I replaced the Polkadot WebSocket API with an HTTP API, and I also updated some README because we are now have to provide archives, the path to archives, and the URL for the archive for the chain we are going to process. And also I made a small PR to remove hard-coded parachain names from config, because now we can use this HTTP API instead. And yeah, I've been thinking how to implement the transition from processing blocks from archive to real-time processing after we process everything from archive. And yeah, I had some discussion with Nazar, and I will create a design first. Once I get the approval, I will start implementation.
Okay. Have we started archiving Kusama yet?
Not yet, because yeah, I reached out to Leo to help me with bootstrapping everything, to create an environment for a new bootstrap node and a Relayer instance.
Okay. So you don't have an environment to work with?
Not yet.
Have you tried testing it locally, or do you have Kusama stored locally on your machine?
Well, yeah, locally it works.
What do you mean? Like, you were able to back up all of Kusama on a local testnet or on a local node?
No, I haven't done complete backup, but I can process blocks from archive, Kusama blocks from archive.
What's the throughput at right now? Has it changed?
I don't know. Nazar did some changes. After that, I haven't tried, so I don't know. I can check and update you.
Yeah, I mean, it's really
it will
critical.
depend.
Go ahead.
Yeah, sorry. I mean, it might depend on the machine. So my speed might be different from Nazar machine or DigitalOcean.
What was the last speed that you had?
Up to 100.
100 transactions per second, or transactions per block?
Per block.
And that's at a 6-second block time or a 1-second block time?
1 second.
So 100 transactions per second.
But yeah, it's not consistent. Like sometimes it's 6 transactions, sometimes it can be like 200. So yeah, I think around 100.
Do we have
On
anything
average.
to measure that, or are we just kind of like eyeballing it from the console output?
I was eyeballing, but yeah.
I mean,
Well,
like
let's
when
look
we
at
do
the
the,
Polkadot.js front end when you see how many events like you have, how many things are inserted.
okay,
That's where you can see how many blocks were included. And it was also very inconsistent for me. I think it was partially because there was a lot of garbage collection running. After optimizations, I was running pretty stable 300 on my machine. But it is still CPU bound, and there are still optimizations required on the Polkadot.js side to make it faster.
300 transactions per second is what you're seeing, Nazar, on your machine?
Yes, with one second block time, and it's pretty consistent. It's like 280, 320, something like that.
But the issue is with Polkadot.js.
Yes, according to profiling, it spends quite a bit of time there. I was trying to eliminate some of the things. I replaced some of the functionality with like manual computation, how big the header is, so we can hash it without like deserializing it properly. But there are still some optimizations to be had.
Okay. Okay, what's the plan for that going forward?
Still having back and forth with guys from Polkadot.js, with maintainers, to merge the changes that I did. They have some concerns. And after that, I guess, depending on what our target is, I can do more profiling and more optimizations. It's pretty tricky because I need to like find where the problem is, understand how it, like why the problem is there, rewrite it, recompile it, try to like substitute into my other project piece of code and run it again and see how different it is. But it's all
Okay.
CPU bound. It's like all either serializing or deserializing something. That's where it spends all the time.
But it's single threaded. There's probably not a simple way right now to make it run in parallel without messing up the ordering.
Yeah, like it would be challenging in this case to use workers to offload it to different threads. Rewriting it in other language is also quite problematic. So I think it still can be made quite a bit faster. Just the question is what is sufficient, what is fast enough basically for us.
How many blocks do we have in Kusama?
Ooh, almost 10 million.
Okay, well, let's do the math. 10 million blocks divided by 300 transactions per second, 1 transaction per block. At 1 second block time is 33,000 seconds. It's 555 minutes, 10 hours.
But that was like the very early history where there is no basically data in the block. It's just a header. It might be slower further down the road. We'll see.
Okay, so it's not number of transactions, it's size of transactions that matters more?
I'm not entirely sure. I
Okay.
think the number of transactions matter a lot because there are certain things like when events are fired, it cares about how many extrinsics you need to go through and that kind of thing. So there is some constant overhead for every item, regardless of its size. But there might be also some overhead for bigger transactions as well.
Okay. Leo, how soon can we have an instance running for Serge to start testing this on?
Oh, if it's real parity, I can do this after this call. I just have to launch the droplet, and I think that I have to create a copy or a snapshot of the current volume, this extra volume storage that we have, and attach it to the Droplet. It's all the data in there, Nazar, right? In the mounted volume. Yeah, it's just that I think that 1 hour.
Okay.
No more.
Yeah, so our number one priority as a team right now is to get this working for everybody. Okay. So yeah, so please, anything like we don't want to block Serge on testing this. Is our, this takes priority over pallet vesting, over everything, is to trying to get this optimized and anything we can do to make this faster. So this looks like it should work in 10 hours optimistically. So let's start this. So we got 1 hour to get a node running. Serge, let's just go ahead and start the script, get it running, go to bed, wake up tomorrow morning, it should be done. If not, we got to figure out what the bottleneck is and start working on improving it. Okay, and so you said you also need to have a design document, and then you're going to submit that to Nazar for review, and then you're going to start working on the code for how to transition between archiving and relaying. It seemed, I mean, is it really that complicated that we need a design document for that?
Well, not necessarily document, just to have a common understanding. So the problem is that when processing blocks from archive, we process, so all chains are separate. There is no dependency, relay chain and associated parachain, right? But when we process real-time blocks, we get the relay chain block and we get the para blocks from the relay block. So there is like a dependency.
Why can't we just have a consistency and have a dependency in the archiving as well?
I'm confused. So I would think about it this way. We essentially just have a bunch of chains backed up in parallel. The only difference is that some chains are currently being read from the archive. Some of them are read from the API, that's relay chain. And some of them get notifications as a result of getting a notification from relay chain. So they basically have different sources of data. But what they are doing at the end of the day is the same. We just get the block somehow, we send the block as a transaction to the subspace. So we just have all of those running in parallel, but how data gets into it is different. That's all there is to it.
Well, if we back up all the parachains in parallel with Kusama, all the parachains are going to finish within 10% or less of the time that it takes Kusama to finish. And then they're all just going to be waiting until Kusama finishes before they can start syncing, because they can't sync beyond what's in the archive until they know what the finalized blocks of Kusama are. So they're just going to be blocked, basically. So it doesn't make any sense to back them up until, I mean, why not just wait until you get to the first Kusama block where there's actually a parachain block, and then just have a consistency just the same way it works in real time for like the light relayer?
Because in that case, you need to decode every single block of Kusama, and you need to have types for all of that, and you need to read and extract all of the information, and then you maybe need to query some other API to actually get that block. So like you will basically get the hash. You need to then transform that hash into the block number so we can reach out to the archive. It's like a lot of things which to me do not make a lot of sense to do. Like if they do nothing, let them do nothing. Why is that a problem?
Okay, well, it just seems simpler to have a consistent way of doing it. Okay, so then we just wait. So okay, so we finish uploading like Akala or Karora, and then we just like, I don't know, I guess we just tell, like, what are you guys thinking? How should this work? Should it just like write it to a file somewhere or flip a state somewhere and then whenever Kusama gets to the head and it starts requesting new blocks, then we start syncing again.
So one way I was thinking to implement this, but yeah, I'm not sure this is the correct one, is to process blocks from archive in parallel. And once it's done, we start with normal mode. And for Kusama blocks, it's pretty straightforward. Like we know what was the last block processed, and if necessary, we just resync and then process new blocks. And we basically do the same for para blocks. Let's say we have a relay chain block, and there are para blocks, and we get if there is any difference between the blocks stored in archive and this para block we get in the new relay block, then we fetch all the blocks that are missing. So first few blocks might take some time, and then we just so basically resync. We do resync for the para chains, similarly to how we do it for the Kusama.
That's what I'm saying. It should all look exactly the same, just slightly different sources of like what blocks needs to be archived.
But in terms of the archives we have right now, Kusama is the oldest, right?
It is the oldest, but
Yes.
all of them are basically not exactly at the same height. They're all
Right.
at different dates.
Right, as we go further along the parachains, they get like more recent. So what would happen is that we would get to, so we would upload, would start with 14 feeds that would all start from 0. And then all the parachains would finish. And then it would take a long time for Kusama to finish. And then Kusama gets to the head and it says, okay, I have nothing left in the archive. Now I need to read from the network. And now explain to me one more time, Serge, what happens after we get to that point with Kusama?
Yeah, so we process the relay block and we check what are the para blocks in the relay block. And we know what was the last process block for this para chain, right? So if there is any difference, then we fetch missing blocks using HTTP API and we add them while processing this relay block. So within our first fresh relay block, it may take some time because we will resync all the parachains which are mentioned in this relay block.
So all those will be done in parallel, non-blocking each other, but until they're all done, they're going to block the next relay block.
Why?
Well, I don't know what would be the actual implementation yet, but this is where I would start. I'm not sure it will block actually, but we need to maintain order, right?
Right.
It should work exactly the same for all of the chains. The only difference is that relay chain will fire event that, by the way, this parachain needs to be archived. That's it. Like you have up to some block in the archive. If you get notification you need to archive that block plus 100, that obviously means that you need to sync the 100 blocks before it first. And that doesn't differ between relay chain and parachain. It can be the same at the parachain as well. So you just sync up to the latest one and then you continue from there. If there are 10 blocks of the relay chain in the meantime, whatever. You just get another notification, we sync another 10 blocks and then we move from there. So like all of the chains should work exactly the same internally, I think.
Yeah, but what I'm saying is if we get to the head of Kusama in the archive, and now we go read the next Kusama block from the network, and now it takes 5 hours to sync all the other parachains up to that, just as an example. Okay. Then are you saying we should keep requesting Kusama blocks in the meantime? Like just keep syncing Kusama blocks in its own separate process?
Yeah.
Okay. But then as we get like if it takes an hour to sync up all the parachains up to that level of Kusama, then we're going to keep processing. Like it feels like there's going to be like some sort of like a queue, like we're going to overload something because we're going to keep processing new Kusama blocks, and then that like we have to remember like, oh, now I need to go get all these, you know, parachain blocks as well that are referenced here, and like
You don't need to remember. You will get a notification in the next block anyway. Just wait a few more blocks and you will get notification.
a notification in the next block of Kusama.
Yeah, that block from this parachain was archived, and you will get information about what block. So you can go figure out what blocks before that you need to archive that are missing.
I'm not understanding. Okay, well, you got so does that make sense to you at least, Serge?
More or less, yes. I think if
Okay.
I have any confusion, I will clarify with Nazar as in the process.
Okay. So can we start writing that?
I think, yeah, I can start implementation actually after this call.
Okay. So, and do we have sync for parachains working?
No, this will be part of the implementation.
Okay, so first, so we don't have parachain sync like
You
from.
mean resync or?
Well, I don't know which one. Do we have parachains from archive working?
It's in review.
Okay.
If there are no issues, then yeah.
Okay, and then what we're talking about is resync, and we already have live sync working.
Yes, for Kusama. So I might re-implement it for parachains.
Okay. So do we have any kind of like honest, realistic estimate of how much more development work until we're going to be able to run like the full product here?
It's getting
Days,
difficult.
weeks, months?
Let's target Friday, can we?
Friday to have all the code. So today's Tuesday. Okay, so 3 days to have all the code reviewed and ready. And at that point, we should be able.
I think it will get reviewed during the weekend. So yeah.
Okay.
Dev ready
Nazar,
on Friday. Okay.
Nazar, can you please, if you have any PRs from Serge regarding the relayer, please make it your priority to get those reviewed as quickly as possible. All right. Okay, so by Friday, we'll have the implementation done, or at least submitted. Then we can have Nazar will review, and then after that's approved, then we can start over another staging relayer from Genesis, start the archive process. That's going to take probably the weekend to run. So maybe by Monday, we can have the full archiver working from Genesis.
I would say it's somewhat optimistic target.
Okay.
It assumes everything went flawless, which is almost never the case.
Okay. Well, we're at least going to have the code submitted by Friday so that we can review over the weekend and start testing and finding the bugs. Okay. So Leo, if you can please make it your priority to get an instance working for Serge so we can at least start testing Kusama back up from Genesis and see how long that's going to take.
Yeah, I'm by the half, actually. I am working right now.
Great. Great. Okay. Okay, anything else you guys want to discuss? Okay. All right, thanks everybody for watching. Hopefully we'll have some great updates for you next week on this. Hopefully it'll be working. We'll see.